What's up, guys? We are back again with another problem. Today, we need to find the most competitive subsequence. We all know what a subsequence is. For example, 3 2 is also a subsequence, 3 6 is also a subsequence. Subsequence is nothing but a subset, and we are given a size k, so we need to find which of the subset of this set of size k is the most competitive. How do we define most competitive subset? If or subsequence, if all the number of a subsequence are less than the given number of another subsequence. So in this example, if we take 3 and 5, uh, that is a subsequence. We take 3 and 2, that is a subsequence. But there's also one condition: this should be sorted. For example, no, what I mean is that uh, 3 and 2 cannot be a subsequence, since 3 is greater than 2. So we have to take 3 5. We can't take 5 2, we can't take 3 2, we can't take 3, we can take 3 6. So it is 3 5, 3 6, 5 6 and 2 6, and out of them we need to compare who has the smallest digit at a particular position. So at position I equals to 0, this has 3, this also has 3, this has 5, but this has 2, so it wins in this one. And since it wins, that is it. We only need to compare this. So if even if this was if this was 4 here, if it was 3 versus 4, 3 comma 4, and it was 2 comma 6, then also we'll pick 2 comma 6 because 2 is lesser than that. So how are we going to do that? First, doing it in like comparing all the numbers, making substrings out of them and comparing all the numbers is not difficult task. What we need to do is we need to pick a number, the smallest number out of this bunch. And what my approach initially was to pick the smallest number once, twice, and return that. But there's an issue: I cannot pick 2 comma 3 because it will disrupt the sequence. So what I have to do is pick the smallest number in this range. This range is nums dot length minus k. I have picked the smallest sequence, which is 3 comma 5. Then what I do is I am at 5 now. Now my range, I decrement my k. Now my range is, because there's only one more element I need to pick, so I prefer this length. In this I choose the smallest, and since 2 is the smallest, I remove 3 and insert 2, so 2 is my smallest. Then I change my length to this. Now I need to find the smallest, which is 2, and other than 2 I have 6, so I do 6. But this is an n square time complexity and it won't be accepted here. So what we have to use is we have to use a stack to maintain all the smallest number. So let's take this example. What I'll be doing in a stack is I'll be checking if the stack is empty, then push this. Then next number, if it's a 4, push a 4. Then for 3, what I'll do is I'll compare if it is less than the previous number or not, and I will also maintain a sorry for that, and I'll also maintain a removable count. So what that count would be, that how many numbers can I remove. My stack should be of size k, so the number that I can remove from the stack must be it should be the length of this array minus k. That is the number of elements that I can remove, so I'll be left with 4 elements. What I do is I insert 2, I insert 4. Then for 3 I check if it is greater than, less than the previously inserted number or not, and if it is, I check if the removable is still applicable or not. If it is, then I remove this 4, I decrement my removable, I insert this 3. Again I check if it is less or not. It is not less, it's equal to. We don't need to take care of that equal to. We'll insert that because the answer is 2 3 3 and 4. Then what I do is for 5 I insert 5. Now my array, now my stacks looks like 2 3 3 and 5. Then I insert 4. Then what happens, I again check if it is less. Yes, I'll check the removable. Yes, it is 3 right now. And I'll check the I'll remove the 5. Then I'll insert the 4. Now my stacks look like this. Then what happens is I insert my 9 because 9 is greater than 4, and then I come on to my 6. Now my k is equal to 2, then I have to remove my 9. My 9 is removed, k is equal to 1. Then my stack is 2, 3, 3, 4 and a 6. What happens then is I check my removable. If my removable still exists, it's still not 0, then I pop the result and I make it equal to 0. That's it. So how I'll be doing this is, if okay, I'll maybe rewrite this whole code. It would be much easier to understand that way. So what I'm doing here is I'm creating a stack of integers. I'll call it st for easy. It would be new stack. Then what I'll do is, after creating that stack, I'll create a int count, how many numbers that I can remove. It would be nums.length minus k. That's the number of element that I can remove. Now what I'll do is, for all the numbers, I'll check for this condition if my st is not empty. So is empty returns empty. If it is empty, so I need to do this. So now it will be false if it is, it will return true if it's not empty. And my count is not equal to 0, another condition, and my num is less than the previous element that I pushed there. If this happens, while this happens not, if what I want to do is, first I want to decrement my count. Along that, what I want my st to be to remove an element, so I'll just use this pop. It will pop. Other than that, I want to push all the elements, so it would be push, and this would be num. Now after that, while my count is not equal to 0, you looked in the example that I need to remove the elements. Again, first I'll decrement my count, I forget about that. Then I'll pop my top. I'll start popping until my count is not equal to 0. Then as you can see, I need to return an array, and my we know all stack is first come last out, so I need to reverse the stack. So I'll create an array first, int what do I name it? I'll name it result, and the size of my array is equal to the value of k, because that's the one we need to return. So for I equals to k minus 1, I greater than or equal to 0, and I plus plus, what I minus minus, sorry, what I'll do is I'll change my results I to be equal to my st dot pop. So I'll be popping all the elements, it would be empty in the end, and then I'll simply return my result array, and that is it. That's all we need to do. This is also called a monotonous stack, where we keep track of all the increasing subsequences or all the decreasing subsequences likewise. And that was it for this question. It was a really simple question, if you of course know the concept of a monotonous stack, that is. Thank you so much.